So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
Welcome to a lesson on the loan payment formula. The goal of the video is to determine the payment for a fixed installment loan. Installment buying is when you purchase something today with a loan that you pay back with equal payments over a period of time, usually monthly for a period of years. The two most common examples would be for a car loan or a home mortgage loan. And we'll take a look at an example of both of these. Here is the loan payment formula for a fixed amount of equal payments, where R is the annual nominal interest rate expressed as a decimal, T is the time in years, N is the number of compounds per year, P is the amount of the loan, and PMT represents the monthly payment. Let's take a look at where this formula comes from. It comes from the compounded interest formula and the value of an annuity formula. So if you're the bank or the lender, you would use the compounded interest formula to determine the return on your investment. And if you were the person taking out the loan, you could use the value of an annuity formula, where P has been replaced with PMT for payment, to represent all of the payments that you would make to cover A, your loan amount, plus all the interest you'd also be charged. So the loan payment formula comes from combining these two formulas or setting them equal to each other. And since these are both equal to A, we can set the right sides of these equations equal to each other. And then if we solve for PMT or payment, we should have our loan payment formula. So let's go ahead and take a moment and do that. So let's go ahead and multiply both sides of the equation by R over N. This would simplify nicely here. So we'd have P times R over N. I'm actually going to go ahead and move this quantity down to the denominator so it'll change the exponent to negative NT. Let's go ahead and continue this on the next page. Now to isolate PMT, we're going to divide or multiply by 1 over 1 plus R over N to the NT power minus 1. So looking at the right side, this would simplify out, and we're left with the payment. So we isolated PMT for payment. Let's see what we have on the left side. Our numerator is still going to be P times R divided by N. Here we're going to multiply. We multiply 1 plus R over N to the negative NT power times 1 plus R over N to the positive NT power. We add our exponents, and that would give us an exponent of 0. So this first product is equal to 1, and then we have minus 1 plus R over N to the negative NT. And this is the formula that we use to determine the payment amount for a given loan in the amount of P. Let's go and take a look at our examples. Determine the monthly payment for a 30-year mortgage loan of $150,000 with a 5% fixed interest compounded monthly. Then determine the total interest that will be paid over the 30 years. So our monthly payment is going to be equal to P, the loan amount, times R divided by N. That'll be 0.05. It's compounded monthly, so N is 12. We'll divide all of this by 1 minus 1 plus r over n to the negative n times t power. Well, n is 12 and t is time in years, so it'll be 30. So our exponent here is going to be negative 360. Let's go ahead and evaluate this. We'll put our numerator in a set of parentheses. So there's our numerator, and we'll divide this by our denominator. And we can see that our monthly payment is going to be approximately $805.23. Now the second part asks us to determine the total interest that will be paid over the 30 years. Well, we're going to make 360 payments of $805.23 for a loan in the amount of $150,000. So let's first determine how much money we're paying over the 30 years. It'll be 805.23 times 12 months a year times 30 years. So we're going to pay $289,882.80 over the 30 years for a loan amount of $150,000. So if we subtract $150,000 from this amount, the rest would be the amount of interest paid. So the total interest that we'll be paying over the 30 years is almost $140,000, or $139,882.80. So notice that we're paying almost as much interest as the total loan amount. Now for our second example, we're going to compare the same loan, but now instead of a 30-year mortgage, we'll take a look at the difference in payments and interest amount if we have a 15-year mortgage instead. So everything is the same here, except now t, the number of years, will be 15 instead of 30. So our exponent here is going to be negative 12 times 15 now instead of 30. So let's see how this affects our monthly payment as well as the total interest paid over 15 years. There's our numerator. And again, our exponent here is going to be negative 180. So for a 15-year mortgage, a loan payment would be $1,186.19. So going back and comparing this to the 30-year mortgage, looks like our loan payment went up more than $350, but the payments would only be for half the time. Let's also compare the interest paid over 15 years compared to the 30-year mortgage. So we'll be making this monthly payment for 15 years, or 12 times a year for 15 years. So here's the total amount paid over the 15 years, and then we'll subtract out the loan amount, and that'll leave us with the amount of interest paid. So we'll be paying $63,514.20 of interest over the 15 years. Again, comparing this to the 30-year mortgage, we'll be paying over $70,000 more of interest if we select the 30-year mortgage. Let's go and take a look at one more example dealing with a car loan. So determine the monthly payment of a 5-year car loan of $20,000 with a 5.5% fixed interest compounded monthly. So it's the same formula. We have $20,000 times 0.055 divided by 12 as our numerator. And our denominator is going to be 1 minus the quantity 1 plus 0.055 divided by 12 raised to the negative nt power. Well, n is 12 because it's still compounded monthly, and it's for 5 years, so t is 5. So our exponent here is going to be negative 60. Let's go back to our calculator. Our exponent here is going to be negative 12 times 5. That'll be negative 60. And there's our denominator. So our monthly payment would be approximately $382.02. And then again, the total amount of interest paid over 5 years will determine the total amount paid, and then we'll subtract the loan amount of $20,000. So of $382.02 times 12, that'll be the amount paid per year, times 5 years. So $22,921.20 is the total amount paid, minus the loan amount leaves us with the amount of interest paid. So almost $3,000 of interest, or $2,921.20. I'd like to make a couple closing comments on mortgage loans. Some mortgage loans have origination fees or points. For each point, the buyer must pay a cost of 1% of the total loan. And some mortgages will also require an additional monthly payment into an escrow account to pay yearly property taxes and insurance. So it's important to be aware of all of the costs when taking a loan. I hope you found this video helpful. Thank you for watching.